A chemistry. Triple A chemistry. So we have started our channel to uplift the chemistry understanding of the students. Okay, right. So the very first series we are going to upload the videos is chemistry basic series. Chemistry basic series. This is the class number 1. In this class, we are going to focus about the fundamental, very important fundamental thing of chemistry, which is elements. Okay, right. So before seeing the elements of chemistry, let us see the elements of this universe. Elements of this universe. What is universe? Actually, where we are? So we are in India. Where India is situated? India is situated in Asia continent. Asia continent is present in Earth. Earth is present in where? It is present in the solar system. Solar system is present in Milky Way galaxy. Milky Way galaxy, the very next galaxy to Milky Way galaxy is Andromeda. So like Milky Way galaxy and Andromeda, there are a lot of galaxies present in this universe. So universe is everything. It includes everything. Okay, what we see, what we feel, what we eat, and what we have, everything is universe. Everything is present in the universe. Okay, so universe is everything. Okay, all right. So before seeing the elements of chemistry, now we are just seeing the elements of universe. So universe is everything. Fundamentally, this universe is made by 5 different types of major elements. 5 different types of major elements. The first major element present in this universe is Earth. The next major component or major element of this universe is water. Okay, right. The next one we can write air. Okay. The next can be sky. Sky is one of the fundamental part of this universe. Okay. The next one, then the last one is fire. The last one is what? Fire. So actually I can say these are the 5 major elements of this universe. 5 major elements of this universe. Okay, right. So everything is present in this universe, I told. Okay, so these 5 major elements themselves contain some chemical elements. Okay, so those now let us translate these 5 major elements into science, particularly in chemistry. So these 5 major elements, now we are translating these into chemistry terms. So in chemistry, we are having actually the chemical elements. So up to date, scientists have discovered 118 elements so far, up to date. Okay, so these are the chemical elements. So these are the fundamental things present in the matter. Okay, right. What is matter? So matter consisting of these 118 elements. Matter is nothing but the thing which is present in the universe, which occupies space and which possesses mass. So which occupies space and which possesses mass is called as what? Matter. Okay, right. So every matter present in the universe is consisting of these 118 different types of elements. Okay. Now we are going to focus about these 118 elements, or at least the most important elements from these 118. We are going to focus. So at the end of this class, you will be very thorough with these elements, and at the end of this class, you will be having some fun and jokes also. So kindly watch. Don't escape from the class. Okay, so kindly watch the class. Okay. So matter is consisting of elements. Okay, right. These elements are further containing atoms. these elements are further containing what? Atoms. Okay. What is an atom? An atom is the smallest fundamental reacting part of the element. So all the elements are made up of atoms. So atom can be defined as there is the smallest fundamental reacting part or reacting particle, we can say. So reacting particle. It is the smallest fundamental reacting particle of the element, which is called as atom. Okay. So scientists have discovered that every atom is consisting of three fundamental particles. Every atom is consisting of three fundamental particles. So three fundamental particles of atoms. What are they? They are nothing but electron, proton, and neutron. So each atom is consisting of these three fundamental particles, electron, proton, and neutron. The name itself says that neutron is what? Neutral, electrically neutral. So neutron symbol is N. It is electrically neutral. So its charge is 0. Okay. Electron, the symbol of electron is small e, we can write, and it is electrically negative. Electron is negatively charged. Okay. So we can put minus sign. Electrically negative, and proton is positively charged. So proton is positively charged, so plus. Okay. Right. So up to now we know that atoms are spherical in shape. At the center of the atom, positively charged protons and neutrons. Positively charged protons and neutral charged neutrons are present in the center of the atom, which is called as nucleus. So nucleus is always positively charged due to the presence of proton and neutron together. Okay. Around this nucleus, in the circular path, electrons are revolving. In an atom, always the total number of electrons will be equal to the total number of protons. That means in an atom, always the total amount of negative charge will be equal to total amount of the positive charge. That's why an atom always remains neutral. As a whole, an atom remains always neutral. For example, if an atom is consisting of two protons in the nucleus, then the equal number of electrons also will be around the nucleus. That's why the positive charge is exactly equal to that of negative charge. Okay. So along with the protons, neutrons also will be there in the nucleus. The only smallest element, that is very first element which is not having neutron, is hydrogen. Okay. Hydrogen. Right. Okay. In the atom, among these three particles, which is having higher mass? Which will be? Let us see the masses of these three particles. The mass of proton is 6.6726 into 10 power minus 27 kilogram. And the mass of neutron is 6.6749, we can write, into 10 power minus 27 kilogram. So if you compare the masses of these two, proton and neutron, you can see that the masses of these two will be nearly same. Both have the masses in 10 power minus 27 kilogram. Okay. The only difference lies in these digits, isn't it? Okay. So I can write the mass of the proton is nearly equal to the mass of the neutron. But strictly speaking, the mass of neutron is slightly greater than that of the mass of proton. Okay, right. And what about the mass of electron? The mass of electron is 9.1 into 10 power minus 31 kilogram. the mass of electron is 9.1 into 10 power minus 31 kilogram. So if you compare the masses of proton and neutron with that of electron, okay, what you can conclude? We can conclude that the mass of electron is very much lesser than the mass of either proton or neutron. Okay, actually, electron's mass will be 1837 times lesser. So electron is this much times lesser in mass than that of proton or neutron, we can say. Right. So protons, neutrons, they are the mass of the atom. Electron, nothing. Okay, that's why the number of protons and number of neutrons together is called as mass number. Together is called as what? Mass number. The total number of protons and neutrons together is called as what? Mass number. What will be the definition of mass number? Can you define mass number? The number which is responsible for the total mass of an atom. The number which is responsible, or the number which concludes or includes the total amount of mass of an atom is called as what? Mass number. What is mass number? It is nothing but the total number of protons and neutrons. Okay. The symbol for mass number is capital A. Mass number is symbolized as capital A. Okay. Right. Okay. So for an atom, we can say mass number. Okay. Right. Now we are going to see about the how the element, these 118 elements are actually written, what are the names of those elements, then what are the symbols of those elements. Is there any number to indicate those elements, atoms? Okay, let us see. It is very interesting. Okay, so already I told that mass number includes only the number of protons and neutrons. Okay, what about the number of electrons? Okay, we know that the total number of electrons is equal to total number of protons. An atom is always neutral, I told. Okay, so by using this concept, we can derive one more number. We can have one more number. That number is actually called as atomic number. That number is actually called as atomic number. So what is the definition of atomic number? Atomic number is the either the total number of electrons or the total number of protons. Either the total number of electrons or the total number of protons is called as atomic number. The number of an atom, actually, atomic number. Always we know that the total amount of, or the total number of electrons will be equal to total number of protons. So the atom is always neutral. By using this concept, we are having one more number, that is atomic number. Okay, so if you want to know the atomic number of an atom, first you have to count either the number of electrons or the number of protons. Okay, will they be different? Will the number of total number of electrons and the total number of protons will be different? No, never. Always in an atom, the total number of electrons will be equal to total number of neutrons. That's why it is always neutral. So the symbol for mass number is, we have given the symbol for mass number what? Capital A. And for atomic number, the symbol is capital Z. Capital Z. Z is derived from the German word Zahl. Zahl means number. In German, Zahl means number. Do you know German? I know German. In German, Zahl means what? Number. Okay, so that's why for atomic number, we are giving the symbol Z. Okay, so what is that? That is atomic number. What does it mean? It means that either the total number of electrons or total number of protons. Okay, fine. Right. Okay, so now let us classify these elements into some types. Okay, let us classify these elements into some types. Okay. Elements, which are the fundamental particle of chemistry. Okay, so these elements are consisting of what? Atoms. So atoms are the smallest fundamental reacting part of the elements. Okay. Now, based on the number of atoms present per reacting particle. Okay. Now, we can call the reacting particle either an atom or a molecule. Either an atom or a molecule based on the number of atoms. So based on the number of atoms. Okay. So actually the total number of atoms present per reacting particle of an element is called as atomicity. What is atomicity? The total number of atoms present per reacting particle of an element is called as atomicity. The reacting particle may be either an atom itself or it may be a molecule. Define molecule. What will be the molecule? What will be the definition of molecule? Molecule is the combination of two or more atoms. If two or more atoms are combined together, then it forms a molecule. Okay, right. If the reacting particle itself contains only one atom, now that atom is said to be monoatomic. If the reacting particle or if the molecule contains two atoms, then it is called as diatomic. So diatomic molecule. Okay, right. If the reacting particle contains three atoms, then it is called as triatomic. If it contains four means four atomic. Four atoms means four means tetra. So tetraatomic. Okay. It can be up to 8 also. It can be 8 also. If the molecule or reacting particle of an element contains 8 atoms, then it is called as octaatomic. So for octaatomic molecules, the atomicity is 8, and for tetraatomic it's 4, triatomic 3, diatomic 2. Okay, right. Let us see the examples of this type. The examples for monoatomic elements. Inert gases like helium, neon, argon, krypton, xenon. Okay, these are all inert gases are present in the atmosphere in the single atomic state. The single inert gas itself is present. There are no two inert gases have joined, and there won't be a chemical bond between two. Okay, they are existing as such in single atomic state. Okay, right. Let us see 2 atoms, 3 atoms, 4 atoms, 5 atoms. These are all otherwise called as what? Molecules. So a molecule is the combination of 2 or more atoms combined together. Okay. And the examples for these diatomic molecules. The very famous molecule. Without this molecule, we can't live. We are breathing in what? Air. Air contains what? Nitrogen and oxygen. Oxygen is very important. So air contains oxygen, air contains nitrogen also. Both are diatomic. Oxygen O2, nitrogen N2. Okay. Chlorine, all the halogens, chlorine, bromine, okay, iodine, okay, so etc. We can write. So these are all examples of diatomic. And for triatomic molecule, example is O3. In oxygen molecule, 2 oxygen atoms are combined to form oxygen molecule, which is O2. O is oxygen atom. O2 is oxygen molecule. O3 is ozone molecule. O3 is what? Ozone molecule. But in nature, oxygen atom does not exist in monoatomic state. It exists in the diatomic state as well as triatomic state. So yeah, this ozone is present in the upper atmosphere, which is called as one of the upper atmospheric layer, ozonosphere, stratosphere. Right, okay. And the molecule which contains 4 atoms is called as tetraatomic. An example for this tetraatomic is, very good example is phosphorus, P4. Phosphorus is in tetraatomic state. 4 phosphorus atoms are tetrahedrally joined together to form the phosphorus molecule, which is P4. And octaatomic molecule. The best example for octaatomic molecule is sulfur. Sulfur is present in the S8 state. S8. 8 sulfur atoms are combined to form the sulfur molecule. Okay. So these are all based on the atomicity. So these are all molecules. Okay. So what is a molecule? A molecule is the combination of 2 or more atoms of same type. 2 or more atoms of same type. Okay. Right. In chemistry, actually, we are telling one more word also. Along with molecule, often we are using compound. Often we are using what? Compound. Compound. Compound itself tells us what? Compound. Combined. Isn't it? Okay. Now we have seen about molecules. Molecules. Okay. What are the basic differences between these two? Molecule and the compounds. Okay. A molecule is the combination of 2 or more atoms. 2 or more atoms of same or different through a chemical bond. This is called as molecule. For example, N2O2 Cl2. So in oxygen, 2 oxygen atoms are combined. They are of same type. Okay, right. Compound. A compound is also, it is the combination of 2 or more atoms. 2 or more atoms of different type. You see the word different. Okay, different. Through a chemical bond. These 2 or more atoms will be present in some definite proportion. This is also more important. In compound, the 2 or more atoms will be present in the definite proportion. But in molecule, the definite proportion may not be present. Okay. In oxygen molecule, just O2, N2, Cl2, all are diatomic. Some are triatomic. In oxygen, O2, 2 oxygen atoms only present. But in O3, 3 oxygen atoms are present. So there is no definite proportion at all. But in the case of molecules, there will be a definite proportion. For example, compounds example, we can say water, NaCl, like that. Molecules, we can say N2, O2, O3, P4. So all we have written, there are what? Molecules. Okay. So from the definition itself, we can see that 2 or more atoms are different. That's why compounds are usually 2 or more atoms are different. Different means what? Hetero. So they are having different atoms. So they are always heteroatomic. Molecules will be always homoatomic, we can say. Homoatomic. So from the first point itself, we are taking the second point actually. So homoatomic, this one is heteroatomic. Homo means same. Hetero means what? Different. Okay. Sir, can we tell, we are telling water as a molecule also, sir. Is water a molecule or compound? Water is molecule as well as compound. Okay. So you see, in water molecule satisfies this point as well as this point. Okay, but oxygen molecule satisfy only this point, not this point. Sir, actually what you are saying, sir? Are you confusing? No. First you confuse yourself and become clear. Okay. So water molecule, NaCl, they are satisfying this point as well as this point. But N2, O2, O3, P4, they are not satisfying this point. They are satisfying only this point. So molecules are always molecules, but compounds are compounds as well as molecules. Yes. Okay. So that point we can write all the compounds are molecules. All the compounds are molecules. But not all the molecules are. Not all the molecules are compounds. All the compounds are molecules, but not all the molecules are compounds. So molecules, compounds, molecules. Water is a molecule as well as compound. NaCl is molecule as well as compound. But N2 is only a molecule. O2 is only a molecule. Okay, right. Okay. So now we know the clear-cut definition or difference between molecules and the compounds. Okay. So far what we have seen. So universe contains 5 major types of elements. Those 5 major types of elements are now seen in terms of science and chemistry. Okay. So these Panchabhuta have 118 different types of elements in chemistry. Okay. What is an element? We know that which occupies space and what is a matter which occupies space and which possesses mass is called as matter. So matter is consisting of all these 118 elements. Okay, right. These 118 elements are fundamentally made by the smaller particles, which are the reacting particles called as atoms. Atoms can be either monatomic or polyatomic. Polyatomic may be diatomic, triatomic, tetratomic, heptatomic. Okay, so at last we have seen about the difference between compound and molecules. Okay, right. Now we are entering into the important part of this elements topic. Let us see the atomic number, symbol, name of the elements. Okay. So chemistry புரியணும் அப்படின்னா elements புரியணும். Elements புரிஞ்சாதான் chemistry புரியும். Chemistry புரிஞ்சாதான் will get joy. சந்தோஷம் வந்தால் தான் மார்க் வரும். சரியா? So chemistry work out ஆகணும்னா you should be very strong in the basics and fundamental. Okay, right. So already I told that actually in our school your name is written in some order, in some specific orders. It may be either alphabetical order or some based on the admission numbers, or some numbers will be given to you. For writing examples also write raised number, isn't it? Okay. So like that, in the same way in chemistry also, scientists have given some numbers to the elements. Already we have seen 2 numbers in the previous part. The one was mass number and the other one was atomic number. So now based on atomic numbers only, the elements are classified basically. Okay. So atomic number is very, very important. Atomic number is very, very important. So we know that there are 118 elements in chemistry. Okay. So atomic number. What is atomic number? It is either the total number of, it is symbolized as capital Z. It is either the total number of electrons or total number of protons. We know that in an atom always these 2 numbers will be equal. That's why an atom remains always what? Neutral. Okay, all right. So atomic number symbol is what? Capital Z. How atomic number is derived? Atomic number is derived from the total number of electrons, or the total number of protons. Isn't it? Okay, right. The next column we can write name of the element. The next column we can write what? Name of the element. And the last column we can write the symbol of the element. The symbol the symbol of the elements. Okay. Okay, listen carefully. If an atom contains only one electron and one proton, proton is positively charged, the electrons are negatively charged, then its atomic number is 1. Atomic number is 1. So atomic number is equal to either the total number of electrons or total number of protons. Okay, if it contains only one electron as well as one proton, means 1 plus 1 not 2, it is 1. The number 1 is given to this category, and the element which is having one electron and one proton is called as hydrogen. Hydrogen. Okay. The symbol for hydrogen is capital H. Okay. Actually, we are giving the symbols from the Latin names of elements. Elements may be having any language names. Okay. Tamil name, English name, Latin name, like that. But in chemistry, the symbols are taken from the Latin name of the elements. For most of the elements, the English names and the Latin names are same only. The English names and Latin names are same only. For very few elements only, they are different. And for hydrogen, the English name is hydrogen and Latin name is also hydrogen. Okay. Usually, the symbols are the very first letters. If very first letter is same for two elements, then we go for the second letter or third letter also. Okay, right. In the case of hydrogen, being the very first element, the symbol for hydrogen is capital H. Okay. If the next element, if the element contains 2 electrons and 2 protons together, what will be the atomic number? 2. Atomic number 2. The name of the elements is helium. The symbol for helium, can we give H? Already H was given to hydrogen. So along with the capital H, the second letter also here we are writing E. So yeah, in writing 2 letters symbol, the first letter always should be in capital and followed by the second letter or some other letter also. But the second letter should be in small, capital followed by small letter. Like this one, you have to write these symbols. Okay. The next one is 3 electrons and 3 protons. Atomic number 3. Next atomic number 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Am I right? Okay. Next to helium, the element is lithium. The 4th atomic number is beryllium. Beryllium. Atomic number 5, boron. Atomic number 6, carbon. Atomic number 7, nitrogen. Atomic number 7 is what? Nitrogen. Atomic number 8, the very famous element, oxygen. Atomic number 9, fluorine. 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 Atomic number 10, neon. Neon's atomic number is 10. What does it mean? Neon has 10 electrons and 10 protons actually. Okay, right. Atomic number 11, sodium. Atomic number 12, magnesium. Magnesium. You have to take care of the spellings also. Magnesium. Atomic number 13, aluminium. Atomic number 14, silicon. Atomic number 15, phosphorus. 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 Okay. Before writing the next atomic number, let us finish this table. Okay. Atomic number 2, helium. Atomic number 3 is lithium. The element with atomic number 3 is what? Lithium. And the element with atomic number 4 is beryllium. Be. Atomic number 5, the element is boron. 6th element is carbon. Symbol for carbon is what? C. Boron is what? 4. Beryllium is Be. Boron is B. Okay. So for boron we have given B, and for beryllium the same B should not be given. Okay. So already I told to distinguish the second letter also here we are writing. Okay. Right. Nitrogen symbol is N. So already we have seen about nitrogen. Nitrogen is actually diatomic N2. In gaseous state, nitrogen is present as diatomic state N2 in nature. Oxygen, the symbol for oxygen is O, but in nature, oxygen is also present in the air as diatomic, so O2, isn't it? But symbol is O. Its molecular form is what? O2. O2 is a molecule, isn't it? Okay, fluorine. Fluorine symbol is what? F. Okay, but fluorine is also, it is an halogen. It is also, all the halogens are in diatomic state. Okay, so it is F2 actually. But element symbol is F, but its molecular form is F2. Okay, and neon. So neon, it is Ne. Neon, it is what? Ne. Sodium, it is Na. Sodium, it is Na. Sir, neon is Ne, okay. Then how for sodium Na? How it will be, sir? Okay. Already I have told that for giving symbols, always symbols should be taken from the Latin word. What is the Latin word for sodium? The Latin word for sodium is natrium. 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 So the symbol Na is taken from the first two letters of natrium. Okay, right. So from atomic number 1 to 10, for 1 to 11, for only one element only, the symbol is taken from its Latin name, isn't it? Right, okay. Now, next, the atomic number 12, the element is magnesium, Mg. For magnesium, actually, we have taken first and third letters, Mag. So actually, the symbol is Mg, first and third letters, capital M, small g. Okay. Atomic number 13 is aluminium, Al. Atomic number 13 is what? Aluminium, Al. If the atomic number of aluminum is 13, then what does it mean? How many electrons does it have? It will have 13 electrons. Then how many protons it will have? Same number, 13. 13 and 13. That's why the atomic number 13 was given. And the element with atomic number 14 is silicon, Si. 15 is phosphorus, P. 15 is what? Phosphorus, P. Already we have seen about phosphorus, you know. For phosphorus, the atomicity is what? 4. So phosphorus molecule in nature is existing as P4. Isn't it? P4. So up to atomic number 15 we have finished. Now next atomic number. Atomic number. The symbol for atomic number is Z. Capital Z. And element name. Element name. Element's name along with the what? Symbol. Along with the symbol. Symbol. So after 15, what is the next number? 16, 17, 18, 19, 20. 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So up to 30, isn't it? Okay, so 15 was phosphorus. So 16. The element with the 16 as atomic number is sulfur. Sulfur. So sulfur will be having 16 protons in the nucleus, and the same number of 16 electrons will be revolving around the nucleus in the circular path. That's why its atomic number 16 was given. Okay, right. So the symbol for sulfur is S. Yes, you are correct. Yes. Okay. Actually, sulfur is what? Octatomic. So it is in S8 state. Okay, right. And the element with the atomic number 17 is chlorine. So the symbol is what? Cl. Cl. So for chlorine, we have taken first and third letters like that of magnesium, Mg. Like for as that of magnesium, for chlorine also we have taken first and third letters, not Ch. It is what? Cl. Simply C means carbon. Cl means chlorine. Okay, right. And the element with atomic number 18, is argon. It is an inert gas. The symbol for argon is Ar. All the inert gases are monoatomic. Single inert gas atom will be existing in nature as such. Okay, right. And the element with the atomic number 19 is potassium. 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 What will be the symbol of potassium? Can we write P? No, sir. P was already given to phosphorus, so we can't. Then PO. No, PO is actually polonium. It is another element. So PO also wrong. Can we give PT? No. PT for platinum. Platinum. Then what will be the symbol for potassium, sir? But the symbol for potassium is it is K. What? It is K. Why K? Why K? K, it is okay, but why K? It is from Latin name. So the Latin name for potassium is Kalium. Kalium. So the first letter from Kalium, so K was taken. Okay. And the atomic number 20, the 20th element is calcium. The symbol is Ca. Simply C means carbon. Okay. Cl means chlorine. Ca means calcium. Atomic number up to 20 are finished. Okay. So atomic number 20 means what? The calcium element, calcium atom contains 20 electrons and 20 protons. That's why it's atomic number 20, isn't it? Okay. Next, atomic number 21, scandium, titanium, vanadium, chromium, okay, manganese. You see symbols, STVCM. CM says TV. Or Star TV is being watched by Chief Minister. Like that you can memorize. Okay, so let it be a type of mnemonic. Right, okay. So STVCM. So atomic number 21 to 25, these are the elements. S for scandium, T for titanium, V for vanadium, C for chromium. Here M for manganese. Okay, the symbol for scandium is Sc. Symbol for titanium is Ti. Symbol for vanadium is V. Chromium, not Ch, it is Cr. It is what? Cr. Cl is chlorine, Cr is chromium. Okay, manganese, M, N, first and third letters, like that of magnesium. Magnesium Mg, manganese Mn. Some students may get confused. They may confuse magnesium and manganese. It is magnesium, atomic number 12, the symbol is Mg. But manganese is having atomic number 25, symbol is Mn. It is manganese, not magnesium. This is magnesium, not magnesium. This is magnesium. Magnesium is magnesium, Mg. Manganese is manganese, Mn. Be clear? Don't be confused. Okay, fine. Next, the atomic number 26. The element is iron. Element is what? Iron. Next, 27th atomic number, Gopal. 28th, nickel. Nickel, not knuckle, it is nickel. 29th, copper. 30th element is zinc. 30th element is what? Zinc. Iron. The symbol for iron is, can we give I? No, sir. I is for iodine. Can we give IR? No, sir. IR is for iridium. What should be given? The symbol for iron is irumb. Iron is, yes, Fe. What, sir? From Latin name? Yes, exactly. The Latin name for iron is ferrum. The Latin name for iron is what? Ferrum. So ferrum is the Latin name. So already Latin names, what are the Latin names already we have given? We have given for sodium, natrium, and for potassium, kalium, and for iron, ferrum. So from ferrum, the first two letters Fe is taken. So the symbol for iron is Fe. And for Gopald, can we use C? No, sir. It was given to carbon. Can we give CO? Yes, it is correct. But while giving CO, you should be careful in writing the size of the letters. For CO, if you write capital C and capital O, it is not Gopal. It is not Gopal. Capital C, capital O means it is carbon monoxide. Okay, you have to take care in the capital and small letters also. Okay, you should be very clear in writing the symbols. For Gopal, capital C and small O. And for carbon monoxide, capital C, capital O. So be clear. And for nickel, Ni. Simply N means nitrogen. Ni means what? Nickel. Simply N means nitrogen. Ne means neon. Na means sodium. Okay. Then Ni means what? Nickel. Right. And for copper, the symbol is Cu. Can we give copper? Can we give the symbol of copper as CO? No. CO was already given to carbon monoxide. Sorry, Gopal here. Okay. Copper to the element CO was already given. And for copper, we should give Cu. Sir, there is no U in the spelling. How can we give U? Yes, Latin name. Yes, Latin name. The Latin name for copper is cuprum. The Latin name for copper is what? Cuprum. 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 So the first two letters from cuprum, Cu taken. Okay, that's why not CO. Okay, and the 30th element is zinc. The symbol is Zatan. What? Zatan. So copper is Cu, zinc is what? Zn. First letter and the third letter from the word zinc. So the symbol is Zn. Okay, copper is what? Cu. Cu. Okay. So while we want to leave from the place, so yeah, we are saying what? See you, bye bye, like that we are saying no. So hereafter you should say while you are leaving from your friends in the evening or at the school leaving time, you can say what? See you, not see you. You can say what? You should say what? Copper. You should say what? Copper. Copper, bye bye. Why copper? Yes. See you means copper, no? That's why. Okay. So we have to actually play with chemistry. So wherever you go and whatever you see and whatever you feel, you have to think in terms of chemistry. You have to see in terms of chemistry. You have to you are eating actually chemistry. Okay, so everywhere you are going, you have to in terms of you have to live with the chemistry like that. Otherwise chemistry will not work out. If you turn into chemistry, then chemistry automatically will come into you. Okay, all right. Let us see some fun in chemistry. Okay. So actually, today's date, let us see, let this be 31/08/2001. This is the today's date, let us see. 2023. Let this be. Okay. Now we are going to translate this date in terms of chemistry into chemistry language. We are translating this number into chemistry language. Can you? Yes. You have to see these numbers as atomic number. Then only. How? Because the first two digits, that is actually what? Date. The next two digits are what? Month. And the last four digits are year. Okay. Right. The first two digits 31. You have to see two digits in terms of two digits. Okay, 31. The element with atomic number 31. 30 we have not written, Up to 31 we have written, 31 we have not written. Okay, so after 30 also, let us see some elements. Okay, then only we can write this type of interesting thing. The element with atomic number 31 is gallium. Gallium. The symbol for gallium is Ga. The symbol for gallium is what? Ga. Let us write up to 118 also, but in random manner. Okay. So after 31, we shall write 40. Then what? 50. Then what? 60. Then what? 70, 80, 90, 100, 110. 110. Can you write 120? No. Can you write 120? No. Why? Sir, actually there are only 118 elements, What about 119 and 120? You have to become scientist and you have to discover it. I keep this as balance, blank. Okay. All the best. Okay. After 110, let us write the last element with atomic number 118. Okay, right, fine. Okay, so the element with atomic number 40 is zirconium. 40 is what? Zirconium. The symbol for zirconium is Zatar. Symbol for zirconium is what? Zatar. And for element with atomic number 50 is, any idea? 50th element, it is a round number. 50. Stannum. The element with atomic number 50 is stannum. Stannum is nothing but it is otherwise called as tin. Oil tin, like that you can see now, the tin is made up of by the element stannum and the symbol is capital S, small n, Sn. Okay, right. And the element with atomic number 60 is neodymium. Neodymium, it is Nd. It is Nd. Okay. And the element with atomic number 70 is ytterbium. Ytterbium. The symbol is Yb. And 80, the element name is mercury. The symbol is not Mg, not me. It's Hg. It's mercury. Why, sir? Mercury, Hg? Because of its Latin name. The Latin name for mercury is hydrogerum. Hydrogerum. Hydrargyrum. So the first letter and far away letter G. Hg. Okay. And the element with atomic number 90 is mercury. Have you seen mercury? It is present in the thermometers. So yeah, it is actually colorless. You can see it is in white color. We can say it is actually colorless. Mercury, it will roll down while you put down. It will roll down, roll over all over the floor. Okay. So actually, it is the only metal in liquid state. Mercury, and it is having higher density also. Iron will float in mercury because of the higher density of mercury. Iron will float in mercury. Okay, fine. Atomic number 90, 90th element. The name of the element is thorium and the symbol is capital T, small h, Th. Okay. And the interesting one, 100th element. The element with the atomic number 100, round number. 50th element was stannum. 100th element, any idea? Fermium. What? Fermium. The symbol is Fm. Fm stands for, not finance minister, Fm stands for fermium. So yeah, we can use in another way also. FM stands for actually frequency modulation. If any radio stations, for example, Kodaikanal FM 100.5, so FM frequency modulation. But in chemistry, in terms of elements, the atomic number 100, the element with 100 is what? Fermium, FM. Okay, 110, the element with atomic number 110 is Darmstadtium. Darmstadtium. The symbol is DS. The symbol is what? DS. And the last element with atomic number 118. 118. The last element is it starts with O and ends with N and the symbol is OG. So oganesson. Oganesson. The symbol is what? OG. Oganesson. It is the last element. It is the 118th element of our elements table. Okay, right? Okay. So actually we forgot to give the chemistry language of this date of birth, so let us give. So this date of birth, let us translate into our chemistry language. So 31st element is gallium. So for 31 we can write Ga dot. And 01 means the 1, the first element with atomic number 1, it is hydrogen. So Ga dot H dot, the 4 digits here, you have to split into 2 digits. 20 and 23. 20th element is what? Calcium. So Ca. 23 means vanadium B. Okay, so you can play with your friends by writing their date of birth in chemistry language also. Okay, so we can write by using the numbers. Okay, so you can ask, sir, what for then the year 2000, sir? What should be written for 2000, sir? Okay, you can ask. Actually, this is for fun only. Okay, for 2000, you can split into 2 digits, 20 and what? 00. For 20, you can write what? Calcium. For 00, what should be written? You just put what? Dash or hyphen. It's enough. Right, okay. Can you tell any jokes in chemistry? It's boring. Class is boring, Let us finish with some jokes. Okay. Shall I? Shall I? Yes. Actually, if you are going to a fruit shop, if you want to eat some bananas, if you want to have one banana means, then what will ask with the vendor? Sir, please give me one banana. Like that you ask. Hereafter, you should not ask like that. Okay, you have to ask in terms of chemistry because he is a chemistry boy, chemistry student, chemistry girl, isn't it? Okay. So what should be asked? What will you ask means, sir, please give me BaNaNa, Ba barium, Na, what? Sodium, 2 sodium. Sir, please give me 1 barium and 2 sodium. 1 barium and 2 sodium. What the vendor will think? He was already okay only, but now what is happening to him? What has happened to him? Sir, sorry, we don't have the like that. Okay, we have only having fruits only. Sir, actually, I asked only banana only. Please give me like that. Okay, so like that you can play with chemistry, the elements, symbols, numbers. You can everything you can play. Okay, you have to play. Subject is a playground. Okay, so while you are waking up in the morning, you can ask coffee with your mom. Okay, in terms of chemistry, by using chemistry symbols, you can ask how will you ask coffee? Coffee, COFFE. Let us rearrange the spelling. COFFE. FE. You will ask with your mom, ma'am, I want 1 cobalt and 2 iron. I want 1 cobalt. I am deficient with the cobalt and iron elements. I want 1 cobalt and 2 iron. What happened to you? Mom, simply give me a coffee, ma'am. Coffee, ma'am. That's why I am asking in terms of chemistry. But your mom is so brilliant. If she is so brilliant, then she will bring a cup of coffee to you. Okay, you can refresh your morning just by drinking the chemistry coffee. Okay, so to become very strong in chemistry, to enjoy your chemistry, to celebrate the chemistry, you should be very strong with the fundamentals. Without fundamentals, we can't build a building of chemistry. If you're very strong in chemistry, chemistry will work out. Sure. Okay. Thank you. Copper.